Hey everybody, Mr. Lamping here. We're taking a look at M-2. This is our Unit M on transformations. We are going to look at reflections this time out in M2. A reflection is something we take a pre-image and we flip it across some line. So some line of symmetry, we'll call it. So a reflection across a line M is called, which is called a line of reflection. This is the line of reflection. It's a transformation with the following properties. If point A is on M, then the image of A is itself. So A becomes A prime. If a point B is not on line M, then M is the perpendicular bisector of B prime. So here's what I mean by that. So here is the line of symmetry, the line of reflection. Here's point B. Point B prime would be straight across, perpendicular to the line of reflection. If this distance were 10, this distance would be 10. So it's equidistant from that line of symmetry. It's basically a mirror image on the other side. So this is a bisector of that segment. Same would be true for C and C prime. If we drew a line here, this would bisect that C prime segment. Okay, that's what that means. You're going to write the reflection across M that takes P to P prime this way. You're going to put a capital R. Capital R stands for reflection. Remember last time we used capital T for translation. Then M is whatever the line is, wherever the line that we're reflecting across. We identify that line. And then what are we reflecting? In this case, point P. And then what does it become? It becomes P prime. So what do reflections do? The properties of reflections are that they preserve distance. So the distances are all the same. BC, B prime, C prime. They're still congruent. AC, A prime, C prime. Still congruent. In other words, the shape is exactly the same size. Doesn't change. The angle measures are exactly the same angle measure. If that angle measures 85 degrees, that angle measures 85 degrees. None of the angles change. Reflections map each point of the pre-image to one and only one corresponding point of its image. So that B goes only to that one exact location. Okay? So that's how this is going to work. We're just simply going to reflect across some line of reflection. And we'll take a look at some examples of this next.